Good evening, friends. So, in today's lecture, we are going to learn about the problem based on three spheres. Okay, so let's look at the problem first. Obtain the reaction at all contact surfaces of the cylinder and the tension in the cable shown in figure. Each cylinder is of weight 1000 Newton and radius of 100 centimeter. Assume smooth surfaces. Okay, so these are three spheres. I have shown like this way. It is based on placed on a smooth surface, and there is one wire, one cable attached at sphere B and C. Okay, on this two sphere there is only one more sphere. Okay, so now what we have to do is we have to obtain the reaction at all contact surfaces. Okay, so first look at how many contact surfaces the spheres have. This one contact surface, 2, 3 and 4, right? Okay, so for this kind of a problem, there are some steps we have designed. So very first step is you have to first find out the geometry of the whole shape. Okay, whole figure you have to find out the geometry. After you work on the geometry, you have to go ahead with the FBD of individual spheres or a cylinder. Then consider the FBD of cylinder first, which is having the minimum unknowns, or you can say we have three equations, so go ahead with the three unknowns. Okay, then apply equation of equilibrium or Lami's theorem according to the demand of the FBD. Okay, so very first thing is the geometry. Now look at this shape A, B and C. Now for drawing the geometry, what I did is I have joined all the lines of this connecting points. Okay, B, A, C, and I have formed this triangle. Okay, so now tell me, this is nothing but its radius, just nothing but its radius, right? So what is the length of AB? AB is nothing but I have mentioned this M and N as a contact point of these two surfaces. So M, so AB is nothing but AM plus MB, right? AM plus MB. AM is nothing but radius of sphere A. BM is nothing but radius of sphere B. And they have mentioned all the sphere is of radius 10 centimeter. So this is 10, 10, 10, 10 and 10. So what is the length of AB? 20. Length of AC? 20. Length of BC? 20. So all sides are equal. 20, 20. So can I say it is equilateral triangle? That means the angle must be 60 degrees. So we got the angles as well as the shape. As well as the length of this shape. Okay. So we are done with the geometry. Now we can say that I got the theta as well as the lengths. Okay. Now the next part is we have to go ahead with the FBD of cylinder. So now what I can do is draw individual spheres and try to draw its FBD. Okay. So hint for this is when you are drawing individual FBD, first try to get the the obvious reactions first. Okay, so if I'll say this sphere is attached at this point, this sphere is touching at this point, this point and this point. So if I'll consider sphere A first, so sphere A first, the obvious reaction is the weight of the sphere. So weight of this cylinder is nothing but 1000. So for that sphere or cylinder, the weight is 1000. So obvious reaction I have drawn first. Then this two contact surfaces, right? So there is a contact, that means there must be some reaction at this points, right? So I consider this as reaction AB for this sphere A and B, and reaction AC for the sphere A and C. Okay, so that is reaction at AB, reaction AB and reaction AC for this sphere. Is there any other reaction for this sphere? This 1, 2 and 3, that's it. Okay, then go ahead for the sphere B. For cylinder B, now there is one contact surface. Okay, this second contact surface, and this point there must be the weight of the sphere. Excuse me. So for this case, This one contact surface, I consider this as a R1. So this, there is one reaction for this contact surface. Then weight of the sphere 1000. Then this point, there is, every action has equal and opposite reaction. So if there is force exerted by the sphere on AB, so on A, so the same force is exerted by sphere A on B. So reaction opposite, same magnitude but opposite signs, RAB on this B sphere. So 1, 2 and 3. There one more force or one more thing we can say, there is cable BC is attached for this two sphere. So whenever there is a cable attached, so we don't need to show the contact reaction. Okay, there is no need for a normal reaction, as we are already said it is attached with a cable. That means if it is gonna pressurize these two spheres, this two spheres gonna spread. So if it is gonna spread, so there must be tension in the cable, so that tension we can show it away from the point. So for the sphere B is nothing but 1000 Newton weight, R1 reaction at point, reaction at this point, tension of this cable and reaction for the B. The same thing is for the point C, same, equal and opposite reaction. Okay, tension for this cable, normal reaction for the sphere, normal reaction for the surface, and the weight of the sphere. So this way we have shown all the FBDs of the cylinder. Now the next step is we have to consider the FBD of cylinder first, which is having the minimum unknowns. If I'll consider B first, it is having 1, 2, 3, 4, 4 reaction. We have only 3 equations. Then if I'll consider C first, then again it is 1, 2, 3, 4, 4 reaction. Bad idea. So if I'll consider sphere A first, so it is having 1, 2 and 3 reactions. That means I can figure out, I can do something with the sphere first if it is possible. So I'll go ahead with the cylinder A first. So I'll draw FBD of cylinder A. So this is 1000, this AB, and this R reaction AB, reaction AC. So we'll draw it like we're gonna use law of transmissibility so that we can collect all kind of forces at one point particularly. So if this is theta, now what about this theta? Here we consider this angle is theta 60 degree, as it is an equilateral triangle. If there is one force acting at this point, we have shown it like this way. So if this is theta, so alternate angle, this is also theta, correct? Opposite angle, this is also theta. So we can say that this reaction AB is theta. So law of transmissibility, I've just transferred this force over here. Law of transmissibility, I have transferred this force over here, and this shape I have shown it over here. This is reaction at RAB, reaction RAC, 60 and 60. So this must be 60 because total is 180. So 60, 60, 60, 180. And this is 1000. So very easy. You can go ahead with the equilibrium equation, summation of f of x is equal to 0 or summation of f of y is equal to 0, or you can go ahead with the Lami's theorem. Okay, so Lami's theorem, here I used Lami's theorem. So reaction at RAC, force divided by sine of opposite angle. So force is RAC divided by sine of opposite angle is in between two forces. This is 90 and this is 60. So sine of 90 plus 60. RAC divided by sine of 90 plus 60 is equal to RAB divided by sine of 90 plus 60. Similarly, 1000 divided by opposite angle sine of 60. Correct? So now we can consider the ratios at a time, two ratios at a time. Like you can compare this with this, or you can compare this with this, and you can get the value of RAB and RAC. So from this process we got the value of RAB 577.35 Newton and RAC 577.35 Newton. This is because it's the geometry. You can say it is symmetry shape, all sphere is of same weight and same radius, so that is why this is gonna be same. But this is not the always case, because sometimes they can give you the different geometrical shapes, like circle of radius 10 centimeter, then the second circle is of radius 15 centimeter, like this way. So it's not the same case. Okay, so like this way we can get the value for this case. Now here if I'll consider sphere B, now here I got the value of RAB. So here we know that 1000 Newton, so two unknown is only R1 and T. So you can go ahead with this. So for this shape I have drawn FBD over here, R1, R1. So I have transferred this over here, R1. This T is as usual, 1000 is here, and RAB I have shifted over this point, RAB, right? Law of transmissibility. Now this figure is over here. Okay, now here there are 1 2 3 4 forces. So still if I know the value of this, that means you can apply Lami's theorem over here like this way, because only 3 are unknown. It is not the case. Lami's theorem you can apply only when there are completely only 3 forces. Okay, so remember that thing. Here I have to go ahead with the general conditions of equilibrium, and that is nothing but summation of f of x, summation of f of y, and moment. So we will consider if f of x and f of y will give me the value, there is no case of moment, because only two unknown. So that means within a two equation I'll get the answer. So if I'll consider summation of f of x, so like this way I'm getting the value of tension. Summation of f of y, I'm getting the value of R1. Okay, same here I got the value of T, so that T is nothing but the same force, but only opposite in direction, same magnitude, opposite in direction. Okay, then this RAC, so only RAC is also we got the value from this equation. That means only unknown is this R2. For this R2 value we have to go ahead for the next sphere. So for this sphere T is already we got the value, RAC also we got the value, 1000 is the known value. So we have to find out the R2. So R2 is only vertical force, so please don't use summation of f of x over here, directly go ahead with the summation of f of y. So you'll get the value of R2. R2 is nothing but 1500 Newton. Okay, so like this way we can solve the whole problem. It is bit lengthy, but it is sort of easiest problem I found in equilibrium. Okay, so please go ahead with some steps in your mind first, and then find the rest of the part. Rest of the part is nothing but just summation of f of x and f of y and all those things. There is not necessarily you have to use Lami's theorem only. Here also you can use summation of f of x and summation of f of y if you want.